You are welcome to InterswitchSPAK Prep. I am Olugona David, your mathematics tutor. On this segment, we'll be looking at mensuration. Now, what is mensuration? Mensuration, in its literary meaning, is to measure. It's generally used where geometrical figures are concerned, where one has to determine various physical quantities such as length, area, and volume. Measuring these quantities is called mensuration. Alright? Mensuration are divided into two basic shapes. One, we have the 2D shapes, which is otherwise known as two-dimensional shapes. We also have the 3D shapes, known as three-dimensional shapes. But to start with, we'll be looking at the two-dimensional shapes, that is the 2D shapes. We have here that a shape that has only two dimensions, such as width and length, and no thickness, are examples of two-dimensional shapes. Below these are some other shapes like the circle, the oval, triangle, square, trapezium, diamond, rhombus, parallelogram, rectangle, pentagon, hexagon, heptagon, octagon, nonagon, decagon, and so on and so forth. All these are examples of two-dimensional shapes. But under this segment, we'll be looking at these basic 7 two-dimensional shapes, namely square, rectangle, parallelogram, rhombus, triangle, trapezium, and circle. Alright, to start with, we have the square. What is a square? A square is a regular quadrilateral, which means that it has 4 equal sides and 4 equal angles, 90-degree angles or right angles. It can also be defined as a rectangle in which 2 adjacent sides have equal length. So that is a square. Now, moving to the perimeter of a square. Perimeter of any two-dimensional shapes is a sum of all the sides. That is, the lateral side bounded by that shape to the addition of all the sides gives the perimeter of the two-dimensional shapes. So, for a square, to find the perimeter of a square, we add up all the 4 equal sides. Assuming the side is A, so the perimeter of a square of side A will be A plus A plus A plus A. That is 4A. So 4A is a formula to find the perimeter of a square, where A is the length of its side. And when we move to the area, if we are given a square of side S, and you have to find the area of a square, like every other two-dimensional shape, the area of any two-dimensional shape is length times breadth. Since a square has 2 equal sides, so the length is equal to the breadth, and to find the area, we are going to have length times length. So if length is S, so the area of that square will be S times X, and that is S squared. Alright? Then we'll move to a rectangle. What is a rectangle? A rectangle is any quadrilateral with 4 right angles. It can also be defined as an equiangular quadrilateral, since equiangular means that all its angles are equal. That is, 360 degrees divided by 4 gives 90 degrees. A rectangle with 4 sides of equal length is a square, and the term oblong is occasionally used to refer to a non-square rectangle. So that is a rectangle. And the figure you have below is example of a rectangle. You can see the 2 parallel sides they are equal, and each angle is right angle. Then to now find the perimeter of a rectangle is 2 times the length plus the width. So if you are given length and width of a rectangle, we add the length and the width together and multiply by 2. Because the two lengths are parallel, so we have 2 lengths, and the 2 widths are also parallel and are equal. That is how we have 2 into bracket L plus W, where W is the width and L is the length. And to find the area, like I've told you, to find the area of any two-dimensional shape is length times breadth. So we are given width and length in a rectangle, so to find the area, we just multiply the 2 dimensions. So length times breadth. So that is how to find the area of a rectangle. So here we have the width and we have the length. So the area of this rectangle is width times length. Now we move to a parallelogram. What is a parallelogram? A parallelogram is a quadrilateral with 2 pairs of parallel sides. The opposite or facing sides of a parallelogram are of equal length, and the opposite angles of a parallelogram are of equal measure. So looking at the diagram you have below is a parallelogram ABCD, where AB and DC are parallel and also equal, and also DA and CB, these 2 sides are parallel and equal. Then angle DAB and angle DCB are opposite angles, so they are equal. Angle ADC and angle ABC are also opposite angles and are equal. So the line AC and line BD are diagonals, and diagonals of a parallelogram bisect each other, but not at right angle. So it only bisects, that is, divide each other into 2 equal parts. So that is the properties of a parallelogram. Then we now go to perimeter of a parallelogram. The perimeter of a parallelogram is 2 times the base plus side length. So we have the base to be B and the side length to be S. So the perimeter will now give us 2 into bracket B plus S. And the area of a parallelogram is base times the height. So where the height is at right angle to the base. So the height is not the side length. So you must be able to differentiate between the side length and the height. The height is at right angle to the base. So when you are given the parallelogram, you must look for the height, then multiply it to the base to give the area of that parallelogram. Alright, we'll now move to rhombus. What is a rhombus? A rhombus is a simple quadrilateral, all of whose 4 sides have the same length. Another name is equilateral quadrilateral. Since equilateral means that all its sides are equal in length, so a rhombus is often called a diamond. You can see the shape in the figure below. A rhombus takes the shape of a parallelogram, but the only difference here is that a rhombus has 4 equal sides, unlike parallelogram. They only have opposite sides to be equal. But in the rhombus, all the 4 sides are equal. They share the same properties in terms of angle. So the opposite angles of a rhombus are equal, like angle ADC and angle ABC. They are opposite angles, they are equal. And also angle DAB and angle DCB. They are also opposite angles and they are equal. And the diagonal AC and DB meet at right angle. In this case, they did not bisect, unlike the parallelogram where the diagonal bisect, but here diagonal only meet at right angle. So this is a property of a rhombus. Now for the perimeter of a rhombus, since all the four sides are equal, so we take the side of a rhombus to be S. So adding the 4S, then the perimeter of a rhombus will be 4S. And for the area of a rhombus is the altitude times the side divided by 2. So altitude times the side divided by 2. And we can also calculate the area of a rhombus by multiplying the length of the two diagonals. So the first diagonal multiply with the second diagonal and then divide the result by 2. So this also gives us the area of a rhombus. So after the rhombus, we now move to triangle. Triangle. What is a triangle? A triangle is a polygon with 3 edges and 3 vertices. It is one of the basic shapes in geometry. A triangle with vertices A, B, C is denoted A, B, C. You can see example of a triangle here. So that is triangle ABC of angle A, angle B, and angle C. But basically, we have 3 types of the triangle. The first one is isosceles triangle. The second is equilateral triangle. And the third is scaling triangle. So what is isosceles triangle? Isosceles triangle is a triangle where 2 sides are equal. So when you are given a triangle where 2 sides are equal, so that type of triangle is isosceles triangle. And another thing about this triangle is that the base angle of that triangle are also equal. The base angles are equal. So it means that in a isosceles triangle, we have 2 sides equal and the base angles also equal. The second type is equilateral. Equilateral triangle is a triangle where all the 3 sides are equal. And an equilateral triangle is also an equiangular triangle. So the sides are equal, the angles are also equal. So equilateral triangle is a triangle with angle 60 degrees each. That is equilateral triangle. And the third one is a scaling triangle. A scaling triangle is a triangle where there is no equal side. So a scaling triangle has 3 different sides. So no side is equal. So when you see this triangle, you should be able to identify them. Alright? So we now move to the perimeter of a triangle. Like I've told you, the perimeter is the sum of all the sides. So since a triangle has 3 sides, so the perimeter of this triangle will be A plus B plus C. But if the triangle is an equilateral triangle, where all the 3 sides are equal, they will not take the side to be S. So then we add 3S together. So that means that the perimeter of that triangle will give us 3S. Can you see it here? This is the perimeter of an equilateral triangle. But if it's not equilateral, then the perimeter will give side A plus side B plus side C. So this is the perimeter of a triangle. Then we look at the area. The area. You know, when you look at a triangle, you see that a triangle is half of a rectangle. When you divide a rectangle into 2 by its diagonal, it gives you 2 triangles. So one of it is half. So that means that if you are looking for the area of a triangle, you can as well divide the area of a rectangle by 2. So that gives us the area of a triangle. That is where this area is derived from. You can see the area of a rectangle is length times breadth. But since there is height, then, and we have base, so from there, we'll now substitute it to be base times height, and you divide by 2. That is how we got area to be half base times height. You can see half base times height. It is assumed that base times height is the area of a rectangle, and half of it, since triangle is half of a rectangle, so half of it will give the area of a triangle. So please take note of that. Now on to trapezium. Trapezium. A convex quadrilateral with at least one pair of parallel sides is referred to as a trapezium. The parallel sides are called the bases of the trapezium, and the other two sides are called the legs or the lateral sides. If they are not parallel, otherwise there are two pairs of bases. So you can see this is an example of a trapezium. We have a trapezium ABCD, and DC is parallel to AB. So now to area of trapezium. Let's have a trapezium of side ABCD. So the area of such trapezium is the addition of all the sides. So from there, the area of trapezium will be A plus B plus C plus D. That is the perimeter, the perimeter of a trapezium. So it's the sum of all the three sides. So to find the perimeter of a trapezium, then you add A plus B plus C plus D. Then we'll move to area. So in a trapezium where there are two parallel sides, AB, and height H, H is perpendicular to B. So to find the area of the trapezium, then we have half A plus B, then times the height. So you add the two parallel sides, multiply by height, then divide the result by 2. So that is the formula to find the area of a trapezium. Alright? So now to circle. The circle. What is a circle? A circle is a locus of a point equidistant from a fixed point. And a circle is not complete until you have the center and the radius. So the distance round the circle, that is, looking at the line, the lateral side of the circle, is called the circumference. And this line, the longest chord, the line that divides the circle into two equal halves, is called the diameter. So let's look at the perimeter. The perimeter of a circle is also known as the circumference of a circle. That's the distance round the circle. And the perimeter, which is the circumference of a circle, can be solved by using this formula, 2 times radius into pi. So that is, to find the circumference of a circle, you have 2 pi r. 2 pi r. And for area, so the area is a semicircular path times radius. So the semicircular path, that is pi r, then times the radius r. Well, we simplify it to give us pi r squared. So pi r squared is a formula to find the area of a circle. And we have it here that the distance around a circle is called its circumference. The distance across a circle through its center is called its diameter. And we use Greek letter pi to find the ratio of the circumference and the diameter. So pi is circumference divided by diameter. So, and the area of a circle is the number of square units inside the circle. So that is about the circle. So now we are now moving to three-dimensional shapes. Three-dimensional shapes. Now, when we talk about three-dimensional shapes, we are talking about shapes that have height, width, and depth. You can see here we have 3 dimensions. Unlike the previous shape, which is 2-dimensional, where you have only length and breadth, it can be breadth and breadth and height. It can be base and height. It can be length and breadth and width. All these are 2-dimensional. But here we're looking at 3-dimensional. The height, that's 1. The width, that is 2. And the depth, no, the length. So you have the length, the width, and the height. These are the 3 dimensions in a 3-dimensional shape. So example of 3-dimensional shapes are the cube, the cuboid, the square-based pyramid, the cone, the triangular prism, the triangular-based pyramid, the cylinder, the sphere, and etc. These are examples of 3-dimensional shape. So, but under this 3-dimensional shape, we'll be looking at these 7 basic shapes. We have the cube, we have the rectangular prism, which is also the cuboid, we have the cylinder, we have the cone, we have sphere and hemisphere, we have prism, and we have pyramid. Before that, the introduction. Under this 3-dimensional shape, unlike in 2-dimensional shape, where we look at perimeter and area. But under this 3-dimensional shape, we're looking at total surface area, the lateral surface area, which is also known as curved surface area, and the volume. So you're looking at 3 things. 1, total surface area. Total surface area is the sum of the areas of all the sides of the 3-dimensional figure. So the sum of all the sides, the sum of the area of all the sides is total surface area. The lateral surface area, which is also known as the curved surface area, is the sum of all sides of a 3D object except its top and bottom bases. So when you take the top and bottom out of the shape, so the rest, when you look at, when you sum the area, then what we are looking for is the lateral surface area, which is commonly known as the curved surface area. And the third one here is the volume. The volume is the amount of 3-dimensional space an object occupies. The amount of 3-dimensional space an object occupies. It can also be the capacity of that object. So all these 3 are what we'll be looking at on each of these shapes. First shape we'll be looking at here is the cuboid. The cuboid. What is a cuboid? A cuboid is a box-shaped solid object. It has 6 flat sides and all angles are right angles. And all of its faces are rectangle. You can see this is an example of a cuboid. You can see the length, you can see the width, and you can see the height. These are the 3 dimensions. So, to look for the lateral surface area of a cuboid, the lateral surface area is the perimeter of the rectangular base times height. And you know the perimeter of a rectangle is length plus width. 2 into bracket length plus width. So this is the perimeter, then times height. When you now simplify further, then we have the lateral surface area, which is curved surface area of a cuboid, to be 2h into bracket L plus W square units, where h is the height, L is the length, and W is the width. And also we have the total surface area of the cuboid. Total surface area is lateral surface area plus area of base plus area of top. So we have the lateral surface area, which is 2h into bracket L plus W, plus area of base, that's length times width, plus area of top, length times width. So when you simplify this, then we are going to have 2 into bracket LH plus WH plus LW square unit. So this is the formula to find the total surface area of a cuboid. And lastly, we have the volume. The volume of a cuboid is the product of all the 3 dimensions. That is, the height multiplied by the length multiplied by the width. So to find the volume of a cuboid, then we have length times width times height, which can also be length times breadth times height. So that is the volume of a cuboid. Now we have a cube. A cube is a 3-dimensional solid object bounded by 6 square faces with 3 meeting each vertices. So we have example of a square, you can see it here. A square is also 3-dimensional, just that all the dimensions are equal. So we have the length, the breadth, which is also the length, and the height, which is also the length, because they are all equal in length. So to find the total surface area of a cube, you can see that the face, the area of the face of a cube is a square. So the face of a cube is a square, and to find the area of a square is L square. So since a cube has 6 faces, so to find the area of a cube, it will be 6 times one face. So 6 times L square, that will give you 6L square. And for the lateral surface area of the cube, now we take the top and the bottom, then we left with 4. We left with 4, so 4 times L square will give us 4L square. And for the volume of the cube, volume is the product of all the 3 dimensions. So volume is the product of the 3 dimensions. So the length times the height times the width. So we multiply these 3. Since they are equal, so now give us L cube. So L cube is the volume of a cube. Now we have the cone. The cone. What is a cone? A cone is a 3-dimensional geometric shape that tapers smoothly from a flat base to a point called the apex or vertex. So this is an example of a cone. You can see the cone, you can see the flat shape, then move smoothly to the apex. You can see this is the apex, which is also the vertex of the cone. The total surface area of a cone is the lateral surface area, which is the area of this lateral surface, plus the area of the bottom, which is a circle. So area of a lateral surface, which is pi RL, then area of a circular face, which is pi R square. So to find the total surface area of a cone, we have pi RL plus pi R square. And we also have the lateral surface, which is pi RL, and the volume of a cone is 1 over 3 pi R square H. Now let me quickly chip this in, that a cone is also a pyramid. A cone is a pyramid. It's a circular based pyramid. So, and for all pyramid, the volume of all pyramid is 1 over 3 times the base area. You can see that the base of a cone is a circle. So the area of a circle is pi R square, then times their height, the vertical height, which is h. That's why we have 1 over 3 base area times height because a cone is a pyramid. And this formula is a general formula for the area, volume of a pyramid. Alright, we now move to cylinder. The cylinder. What is a cylinder? Now a cylinder is a shape with two circular faces and a flat surface, a rectangular surface. So we have two circular surface at the top and at the bottom. So then a rectangular face at the middle. So you can see this diagram is a cylinder of radius r, altitude h, and base. So now look at the total surface area of a cylinder is the lateral surface area, which is 2 pi rh, then plus the area of the top plus area of the bottom. You can see both the top and bottom, they are circular. So their area is pi r square. So the area here is pi r square. The area here is also pi r square. So when you add it together, give it 2 pi r square. So when you add it to the lateral surface, then the total surface area will give us 2 pi rh plus 2 pi r square. When you factorize, then you have 2 pi r into bracket r plus h. So that is the total surface area of a cylinder. Now the lateral surface area. The lateral surface area of a cylinder is 2 pi rh. We have discussed that. That's lateral surface area. And the volume of a cylinder is pi r square h. That is the area of the base times the height. So that cylinder is also a prism. This is the general formula for the volume of a prism. So a prism will be the base, the area of the base, then times the height. Since the base of a cylinder is a circle, so the area of a circle times the height. So that's where we got our pi r square from. Now we now go to pyramid. What is a pyramid? A pyramid is a structure whose outer surfaces are triangular and converge to a single point at the top, making the shape roughly a pyramid in a geometric sense. You can see the figure here is the real figure, the practical figure of a pyramid, the real one. While here we have the shape, the geometric shape of a pyramid. So, to find the total surface area of a pyramid, we have 1/2 times the perimeter of the base times the slant length. You can see the perimeter of the base times the slant length plus the area of the base. This B is area of the base. So this P is perimeter of the base, while this L is slant length. And the lateral surface area of a pyramid is 1/2 times the perimeter of the base times the slant length. And while the volume of a pyramid, you can see, like I've said earlier, is 1/3 area of the base times height. So that is the volume of the pyramid. We now go to prism. Prism. A solid geometric figure whose two ends are similar, equal, and parallel rectilinear figure, and whose sides are parallelogram, is called a prism. You can see the figure below. This is triangular prism. You can see the face, triangle, triangle. You can see that. Why the surface is rectangle. So the two ends here, we have the first end triangle, the second end triangle, and they are similar. They are similar triangle. And the outer face here is a rectangle. So this is triangular based pyramid. Prism, triangular based prism. Okay, now going by the lateral surface area of a prism. To find lateral surface area of a prism is the perimeter of the base times the height. The perimeter of the base, so this base, the perimeter of this base, then times the height of the prism. So the total surface area of a prism is the lateral surface area plus 2 times area of the base. So find the total surface area. You have the lateral surface area plus 2 times area of the base. So that is the formula to find the lateral surface area. Don't forget, the lateral surface area is also known as the curved surface area. And the volume of a prism is the area of the base times height. Area of the base times height. So that gives the volume of the prism. And here, we're looking at the sphere. The sphere. What is a sphere? A sphere is a perfectly round geometrical and circular object in 3-dimensional space that resembles the shape of a completely round ball. So you can see this is an example of a sphere. A completely round ball. So ball is spherical in shape. So the total surface area of a sphere is 4 pi r squared, while the volume of a sphere is 4/3 pi r cubed. And when we talk about hemisphere is half of a sphere. So in that sense, the total surface area of a hemisphere will be this divided by 2. That will give us 2 pi r squared. And the volume of hemisphere is this divided by 2, which is 2/3 pi r cubed. So this is sphere. Now, how do you know the number of vertices, faces, and edges of a 3-dimensional shape? How do you know? Now, there's a formula called Euler's formula. Euler's formula shows how to find any, like when you have the face of a 3-dimensional shape, and we have the vertices. Then, so when you have the faces and the vertices, then you can easily find the number of edges in that shape by making the social formula. So now have f plus v minus 2. That will give us the formula to find the number of edges. Or if you have edges and you have vertices, you are looking at the faces. So that will be e plus 2 minus v. So you just make any one social formula and then you find the number. So we can see that here our f is the number of faces, our v is the number of vertices, and our e is the number of edges. So this formula is called the Euler's formula. Euler's formula. So let's look at the table showing some shapes with their number of faces, vertices, and edges. Looking at this, we have shape, we have faces, we have edges, and we have vertices. So for triangular prism, a triangular prism has 5 faces, 9 edges, and 6 vertices. A cube has 6 faces, 12 edges, and 8 vertices. A square pyramid has 5 faces, 8 edges, and 5 vertices. In hexagonal prism, then we have 8 faces, 18 edges, and 12 vertices. Cuboid, we have 6 faces, 12 edges, and 8 vertices, just like a cube. An octahedron has 8 faces, 12 edges, and 6 vertices. And lastly, but not the least here, we have hexagonal pyramid. So we have 7 faces, 12 edges, and 7 vertices. So these are examples. So this now, I will now give it to you as viewers to go and find the name of this shape, number of faces, number of edges, and number of vertices. Ditto to this and everything here. Give their names, give their number of faces, give their number of edges, and also give their number of vertices. Alright, so here now, we now move to exercises. Question 1. The slant height of a cone is twice its base radius. The slant height of a cone is twice its base radius, r. Express the surface area of the cone in terms of pi and r. The first is to write the formula for total surface area of a cone, which is pi r L plus pi r square. So we have it there. Since our L is twice r, so when you substitute it, it gives 2 pi r square plus pi r square. Adding 2 pi r square to pi r square, then the answer is 3 pi r square. So 3 pi r square is the formula to find the total surface area of the cone in terms of pi and r. Alright, the second question, we have a rectangular plot has a ratio of 5 to 3 between length and breadth. If the perimeter of the plot is 320 centimeters, what is the area of the plot? Now, what's the formula of perimeter of a plot? Perimeter. So you have the perimeter to be 2 into bracket length plus breadth. Then when you substitute the value for the perimeter, 320 equals 2 into bracket length plus breadth. And we divide both sides by 2, then we have 160. 320 divided by 2, 160. Then 160 is the sum of length and breadth. So to now look for the ratio for length is 5, and the one for breadth is 3. So to now find for length, that will be 5 over the sum of the ratio, which is 8, then times 160. This will give us 100. And for breadth, 3 over 8 times 160. That will give us 60. So the length is 100 and the breadth is 60. So to now find the area of a rectangle is length times breadth. So from there, we have 100 times 60, which is 6,000 centimeters square. So that's the area of the plot. The third question here is that a parallelogram of area 625 centimeters square has a height of 25 centimeters. The length of the base is, now what's the area of a parallelogram? Base times height. You can see it. We are given the area to be 625. We are given the base. When we are given the height to be 25, then we are looking for the base. So when you divide both sides by 25, then we have 625 divided by 25. That will give 25 centimeters as the base of the parallelogram. The next question is, a tank in the form of a cuboid has length 12 meters and breadth 4 meters. If the volume of the tank is 72 meters cubed, find the height. Now we record the volume of the cuboid, the formula. which is length times breadth times height. We are given the volume to be 72, then the length is 12, then the breadth is 4. When we multiply, give us 48h. Divide by 48 to find the value of h to give us 1.5 meter. 1.5 meters is the height of the tank. Alright, the next question. A prism of cross-sectional area 18 cm square has a volume of 72 cm cube. What is the height of the prism? So here now, first, let's have a volume of a prism. Volume of a prism is base area times height, which is also the cross-sectional area times height. We are given the volume to be 72. We are given the cross-sectional area to be 18, then times height. So from there, we divide by 18. So we divide through by 18, so our height will be 4 centimeters. So therefore, the height of the prism is 4 centimeters. The next question, we have here that the total surface, the surface area of a rectangular prism is 930 meter cube square. Find the length of the prism if the width and the height are 12 meter and 9 meter respectively. So, to find the total surface area of a cuboid, the formula is 2 into bracket LH plus BH plus LB. When you substitute our area, the total surface area to be 930, the length to be 12, the width to be 12, and the height to be 9. So we have something like this. So we have 21L plus 108. Collecting items, so we are going to have 465. First, we divide 930 by 2. We have 465. Then take this, have minus 108. They give us 357. Divide both by 21. Then the length of the prism will be 17 meters. So 17 meters is the length of the prism. Alright? Two sides of a parallelogram are 4.5 meter and 2.4 meter long. Find its perimeter. You know the perimeter of a parallelogram is 2 into bracket base plus the side. Base times the side. So we have 2 into bracket 4.5 plus 2.4. Then we have 2 into bracket 6.9, which is the addition of 4.5 plus and 2.4. Then we multiply 2 by 6.9, we have 13.8 meters. So 13.8 meters is the answer to find the perimeter of this parallelogram. Alright, we have a measuring cylinder of radius 3.5 centimeter contains water to a height of 56 centimeter. If this water is poured into a similar cylinder of radius 14 centimeter, what will be the height of the water volume? Now first, we have two cylinders here. Since cylinders are similar and you are pouring water from the first cylinder into the second cylinder, so it means that the volume of water in the first cylinder is the same volume of water we are going to have in the second cylinder. So that's why we have it here, that the volume of the first cylinder is equal to the volume of the second cylinder, but of different radius and height. So, since the volume of a cylinder is pi r square h, so we take pi r square h, small r, small h for the first cylinder, then capital letter R and capital letter H for the second cylinder. So to now find the value of capital letter H, which is the height of the water now in the second cylinder, we divide both sides by pi capital letter R square, which is this. So from here now, pi, we take care of pi. Then we have the R, which is 3.5 square, times the height, the initial height, which is 56, all over the radius of the new cylinder, the second cylinder, which is 14 square. When you simplify this, you get 3.5 centimeters. So 3.5 centimeter is the height of the water column. Alright? How many vertices does a cuboid have? A cuboid. You know, a cuboid, you look at the vertices, then there are 8. The vertices is a point where 2 or more lateral lines meet. So you have, if you draw the cuboid and then you count, then you see that you have 8 vertices. So a cuboid have 8 vertices. A rectangle is 16 centimeter long and its perimeter is 60 centimeter. Find the breadth of the rectangle. Now, to find the breadth of the rectangle, first look for the perimeter of the rectangle, which is 2 into bracket length plus breadth. So we are given the perimeter to be 60. So 16 equal to 2 into bracket, the length is 16 plus the breadth. So divide both sides by 2. So 60 divided by 2 is 30. So we have 16 plus b. Collecting like terms, you have 30 minus 16, which is 14 centimeters. So therefore, the breadth of the rectangle is 14 centimeters. Here, the volume of a cone is of radius 3 centimeters and vertical height 7 centimeters is where we are given the value of pi to 20/7. So to find the volume of a cone, you know the formula to find volume of a cone is 1/3 pi r square h. Then we have 1/3 times our pi. 20/7 times our r, 3, then square, then times the height, 7. When you simplify this and use your calculator to multiply, you have 66 centimeter cube. So that is the volume of the cone. Now, we are given that the altitude of a triangular field is 3 times its corresponding base. If the cost of plying the field is plying the field is 15 naira per square meter. Like if the cost of plying the field at the 15 naira per square meter is 20,250 naira, find the altitude of the field. The altitude is also referred to as height. Now, since the field is triangular, so the area of a triangle is half base times height. And we are given that the altitude, which is height, is thrice the base. So altitude is 3 times the base. So from there, we are going to have the area of a triangle to 3/2 b square. And per 15 naira square meter of the field, the cost is 20,250. 20,250. So to find our b, we just have to cross multiply 2 by 20,250, then divide by 15. When you do that, you get 2,700. So divide both sides by 3, so b square will be 900, and b will be square root of 900, which is 30 meters. So b is 30 meters. Since we have to find the height, and the height is 3 times the base, so we now have height to be 3 times 30, and that will give us 90 meters. So 90 meters is the altitude of the field. Now we have a shape has 10 faces and 15 edges. How many vertices does it have? Now, using Euler formula, f plus v equals e plus 2. So we are given f to be 10, we are given e to be 15. So when you substitute, so 10 plus v equals 15 plus 2, which is 17. By collecting like terms, our v will be 17 minus 10. So that will be 7. So therefore, the shape has 7 vertices. So there are 7 vertices in the shape. And lastly, we have a polyhedron has 6 vertices and 8 faces. How many edges does it have? Just using the same formula, the Euler's formula. So we are given vertices to be 6, then we are given faces to be 8. So 8 plus 6, that will be 14. So 14, to find edge, the number of edges, you take 2 to that side. Here we have plus, to turn to minus. When you subtract 2 from 14, then we have 12. So that shows that the polyhedron has 12 edges. So 12 edges. So that is that. So with this, I want to say thank you to everyone for your time. So we have come to the end of our topic, mensuration. So apart from the exercises that have been solved, I will advise every one of you to get other materials, maybe your textbooks or the past question series, that from NECO or WAEC, and solve more questions under this topic. So until we meet again, I say bye for now and good have a wonderful time.